Hello everyone, we are going to see about solar cell in this video. A solar cell, also known as photovoltaic cell, which converts sunlight into electricity. It is primarily constructed with a p-n junction formed by layers of p-type and n-type semiconducting materials, typically silicon. Sunlight composed of photons excites electrons in the semiconductor, creating electron-hole pairs. These charges then migrate to opposite side of the junction, creating a voltage and current when load is connected. Fabrication of solar cell. See in the figure, this is substrate. On the substrate, n-type layer is grown. Over that, p-type layer is grown. A glass window is provided at the top for the sunlight to enter. At the ends of the glass window, ohmic contacts are provided. This is load resistor. A solar cell is made up of heavily doped p and n-type materials grown over the substrate with a larger exposure area for the sunlight to pass through it. The thickness of the p and n region is made small so that the charge carriers generated in this region can easily diffuse to the junction. The p and n type material is connected to the load resistor RL through ohmic contacts. The symbol of the solar cell is shown here. Next, operation. The solar cell is exposed to light without load resistance and the photons are allowed to fall on the p and n type materials. Shown here. These photons collides with the valence electrons and eject it out from the parent atoms, thus electron hole pairs are created. These electron hole pairs quickly diffuses and reaches the depletion region. This is the depletion region. Now, due to strong barrier field, the electrons from p type move towards n side and similarly holes from n type move towards p side. That is, minority charge carriers from both the regions move to other side. Here, electrons from p type move towards n type, holes from n type move towards p side. As the p-n junction diode is open circuited, the electron and holes accumulate on either side of the junction, which gives rise to open circuit voltage V0 shown in this figure. Now, if the load resistance RL is connected across the diode, then a reverse current IR flows through the circuit. Here, the magnitude of current generated in the solar cell is proportional to the intensity of the light falling on it. Next, materials used in solar cell. The material used in solar cell must possess a band gap close to 1.5 electron volt to optimize light absorption and electrical efficiency. Commonly used materials are silicon, gallium arsenide, cadmium telluride, copper indium diselenide. Criteria for materials to be used in solar cell are: the materials must have band gap from 1 electron volt to 1.8 electron volt. It must have high optical absorption. It must have high electrical conductivity. The raw material must be available in abundance and the cost of the material must be low. Advantages of solar cell are: it is a pollution-free device, eco-friendly and save electricity charges, must last for long time, no maintenance cost. The disadvantages are it has high cost of installation and it has low efficiency, it requires more space. During cloudy day, the energy cannot be produced and also at night it will not get solar energy. We will not get solar energy. Uses of solar generating systems, charging batteries, calculators, water heating systems, space heating, industries, power pumps, light meters, power calculators, wristwatches, spacecraft, etc. Conclusion. Though solar cell has some disadvantages associated with it, the disadvantages are expected to overcome as the technology advances. The cost of the solar panel as well as the installation cost will decrease down so that everybody can afford to install the system. Furthermore, the government is also laying much emphasis on the solar energy. So, after some years, we may expect that every household and also every electrical system is powered by solar or the renewable energy source. Thank you.